All right, so get this. We're diving into this world. That most people don't even know exists. Like all those tiny bits of code that make AI run faster.
Yeah.
Especially on those powerful graphics cards, GPUs.
Oh, yeah, GPUs for sure.
We're talking about optimizing the core of AI. And even if you're not a programmer, trust me, the implications are huge.
Oh, absolutely.
Like think self-driving cars reacting faster, medical diagnoses becoming more accurate.
Right.
All because the AI behind them got a speed boost.
Yeah. It's like we're going behind the scenes of the AI revolution.
Yeah.
To meet the unsung heroes.
Right.
The code optimizers.
The code optimizer.
To make everything tick.
Exactly. And get this, we've got this research paper detailing a brand new system called the AI CUDA Engineer.
Wow. The AI CUDA Engineer.
That could completely change how this optimization game is played.
Interesting.
So our mission today is to figure out, what does this AI system actually do?
Yeah.
Why should you care? And trust me, there are some seriously cool aha moments along the way.
The best part is that we're talking about potential advancements in virtually every field imaginable.
That's huge.
Imagine faster drug discovery leading to cures for diseases we thought were incurable.
Let's unpack this AI CUDA Engineer then.
Okay.
In simple terms, what's it all about?
It's an AI system that can write and optimize CUDA code automatically. Think of it like this. Usually highly skilled humans spend hours, even days, tweaking code to make it run faster on GPUs.
Yeah.
This AI system does it on its own.
Hold on. So it's like having an AI programmer who's obsessed with efficiency?
Exactly.
Whoa.
And that's huge because up until now, code optimization was a major bottleneck.
Right.
It's one of the reasons why progress in AI can feel slow sometimes.
Okay, so this AI sounds like a game changer.
Yeah.
But how does it actually work? What's going on under the hood?
At the heart of the system is a large language model, or LLM.
Okay.
You can think of LLMs as super smart language whizzes that have been trained on mountains of data.
Wow.
They're the ones writing the code here.
So it's like an AI programmer that can churn out highly efficient code.
Yes.
That's wild.
It is pretty wild.
But there's got to be some kind of process, right? They can't just magically spit out perfect code.
You're right. There's a clever four-stage process.
Okay, a four-stage process.
First, the AI takes real-world code, which can be pretty messy.
Yeah, real-world code can be messy.
And translates it into something it understands. Imagine taking a rambling sentence and making it clear and concise without losing the meaning.
Okay, so it needs to clean up the code first.
Right.
What happens next?
That's where things get interesting.
Okay.
In stage two.
Stage two.
The AI translates that simplified code into CUDA.
Okay.
The language specifically for programming GPUs.
Gotcha.
And here's the kicker. And make sure the code actually works on those GPUs.
It works.
No gibberish, just functional code.
Wait, so it's not just translating?
Right.
It's actually making sure the code runs properly on a GPU.
It is.
That seems like a big deal.
It is a big deal. And then we get to stage three.
Stage three.
Where the magic really happens.
Ooh, the magic.
The AI starts experimenting with different ways to make that code run faster on the GPU.
Okay.
It uses a technique called evolutionary optimization.
Evolutionary optimization.
Which is basically like natural selection for code.
Okay.
It tests different variations until it finds the most efficient one.
So it's like survival of the fittest, but for lines of code.
A perfect analogy.
I like that.
And then, like a good student, the AI remembers what worked before.
Right.
And uses that knowledge to help with future tasks.
Mark.
This is called retrieval-augmented generation.
Retrieval-augmented generation.
It's like having a library of coding solutions it can tap into.
Oh, that's cool. So it's constantly learning and getting better at optimizing code.
Exactly.
Wow.
And this all ties back to a bigger picture.
Okay. The bigger
AI is getting incredibly complex.
Uh-huh.
And needs more and more computing power to run.
Yeah, that makes sense.
There's this concept called scaling laws.
Scaling laws.
Which essentially says the more compute data and model size you have, the better AI performs.
So bigger is better when it comes to AI?
In a lot of cases, yes.
Okay.
But here's the catch.
Oh.
The demand for computational power is outpacing our ability to create faster hardware.
Oh, I see the problem.
Think of it like trying to fill a swimming pool with a garden hose.
Okay.
It's just not fast enough.
So we have these powerful GPUs,
Right.
but there's still not enough to keep up with AI's growing appetite for power.
Exactly, and that's where this research comes in.
Okay.
The AI CUDA Engineer offers a different approach.
Okay. A different approach.
What if instead of building bigger and faster hardware,
Yeah.
we make the code itself more efficient?
So it's like squeezing more performance out of the hardware we already have.
That's a great way to put it.
That's pretty clever.
It is.
But before we go any further, I have to ask.
Go ahead.
What exactly is CUDA?
Right.
You keep mentioning it,
Right.
but I'm not sure I fully grasp it.
It's the language developers use to unlock the power of GPUs for AI.
Okay.
Imagine trying to have a conversation with a supercomputer.
Okay.
You need a special language it understands.
Right.
And that's CUDA.
Gotcha.
It allows us to tap into the parallel processing capabilities of these chips,
Okay.
which is like having an army of processors working together.
So it's like a secret language that lets you talk to the GPU and tell it what to do.
Precisely.
But you mentioned it's notoriously difficult, right?
Absolutely. Like, why is that?
Even experienced programmers struggle with it because it requires deep knowledge of both software and hardware.
Oh, wow.
There's a steep learning curve,
Yeah.
and very few people are fluent in CUDA.
So this is where the AI CUDA engineer comes in and saves the day.
That's right.
It takes the pain out of writing CUD code.
Exactly.
That's awesome.
And that's what makes this research so exciting.
It has the potential to democratize access to GPU programming,
Democratize it.
making it easier for researchers and developers to accelerate their AI applications
All right.
without needing to become CUDA masters themselves.
So it's like having an AI translator for a super technical language that most people don't speak.
A perfect analogy.
That's pretty cool, but I'm curious,
Yeah.
did they actually test this AI CUD engineer
They did.
to see if it's as good as they claim?
They put it through its paces.
Okay, how'd they do that?
They use something called KernelBench.
KernelBench.
Think of it like an obstacle course for AI
An obstacle course.
that tests how well it can write and optimize CUDA code.
Okay.
It has different levels,
Different levels.
from simple tasks to really complex ones to see what the AI can handle.
Okay, so it's like putting this AI programmer through a series of coding challenges.
Exactly.
I like that.
And the results are pretty impressive.
Okay, what were the results?
They found that the AI was able to translate over 90% of the 250 operations in KernelBench
90%.
and optimize 75% of them to run faster than existing methods.
Wow.
In many cases, it was beating human-written code.
Hold on, so it's not just translating, it's
Yeah.
actually writing better code than humans.
That's what the results suggest. Yes.
Wow.
And to really put it to the test,
Okay.
they focused on a case study with ResNet 18,
ResNet 18.
which is a famous architecture used for image recognition.
Okay.
It's a complex model, but the AI was able to translate it successfully
Wow.
and outperform both the original code and a state-of-the-art compiler.
So it's not just theoretical, it's
Yeah.
actually working on real-world AI models.
It is.
That's pretty amazing. But what does this all mean for someone like me, or even our listeners who might not be programmers?
Yeah.
Why should we care about some AI writing code for graphics cards?
That's a great question.
Yeah.
And it brings us to why this research is so important.
Okay.
Faster GPUs mean AI becomes cheaper and more powerful,
Right.
which has huge implications for all of us. Imagine personalized cancer treatments becoming affordable,
Wow.
or new drugs being developed in a fraction of the time.
That would be incredible.
That's the kind of future faster AI could unlock.
Okay, so it's not just about faster phones and cooler video games.
No.
It's about solving some of the biggest challenges humanity faces.
Precisely.
Wow.
And that's just the tip of the iceberg.
Okay.
This AI has the potential to revolutionize scientific discovery,
Right.
accelerate research in fields like medicine and climate change,
Uh-huh.
and even help us design more efficient energy sources.
So it's not just about making AI faster.
Nope.
It's about making the world a better place.
Exactly. This research really highlights how AI can be used as a tool for positive change.
That's awesome.
But of course, it's important to acknowledge that it's still early days.
Right.
There are limitations to what the AI can do,
Yeah.
and we need to be mindful of how these systems develop.
So there are still challenges to overcome,
Yes,
but the potential is huge.
it is.
This is definitely something I'm going to be keeping my eye on.
Me too.
But for now, let's take a deeper look at this KernelBench thing.
Okay.
You mentioned different levels of difficulty, right? How did the AI actually perform on those different levels?
That's a great place to pick up.
Okay.
What they found is that the AI excelled at different levels depending on the complexity of the task.
Okay.
For example, at level 1,
Level 1.
which focuses on basic operations.
All right.
The AI was incredibly capable, even outperforming human-written code in some cases.
Wow.
But as the tasks got more complex, things got more interesting.
Ooh, more interesting. So the AI aced the beginner levels. What about the more challenging stuff?
Well, level 2 was all about fused operations,
Used operations.
which are essentially the combining multiple operations into a single, more efficient one.
Okay.
It's a technique used by expert programmers to squeeze out more performance.
So like taking a paragraph of code and condensing it into a single super efficient sentence.
Exactly. And even at this level, the AI was able to translate most of the tasks, although the speedups weren't as dramatic as at level 1.
Okay.
Still, the fact that it could handle these more complex operations at all is a testament to its capabilities.
Okay, so it's doing pretty well. What about level 3?
Yeah.
That was the one with the real-world AI architectures, right?
Yes, level 3 was the ultimate test,
Ultimate.
featuring complex architectures like ResNet 18.
Okay.
Here, the AI's performance was a bit more mixed.
Okay, more mixed. How so?
It was still able to translate a significant portion of the tasks, but the speedups were generally smaller.
So it's not quite ready to replace human programmers just yet.
Not entirely, but remember, this technology is still in its early stages.
Right.
The fact that it can even translate and optimize these complex architectures at all is a huge leap forward.
That makes sense. But they also mentioned something about retrieval-augmented generation, or RAG.
Yeah.
What was that all about?
Yes, RAG. This is where the AI really starts to shine. Essentially, it's able to learn from a massive data set of previously translated and optimized kernels.
Okay.
Think of it like having access to a library of coding solutions.
Gotcha.
When the AI encounters a new task, it can search through this library for similar examples and use that knowledge to guide its own translation and optimization process.
So it's not just writing code from scratch every time.
Right.
It's learning from past experience and getting smarter over time.
Exactly.
That's pretty cool.
And this array technique turned out to be incredibly effective, significantly boosting the AI's success rate for both translation and optimization.
Wow.
It's like the AI is building on the collective knowledge of countless programmers who came before it.
Wow. This AI is like a coding prodigy with a photographic memory.
It kind of is.
But let's shift gears for a second.
Okay.
I'm really curious about this massive data set of CUDA kernels that the researchers released.
Yes.
Why would they just give that away?
It's a testament to the open science community. They believe that by sharing their work, they can accelerate progress in the field and inspire others to build upon their discoveries.
That's awesome. Imagine all the cool things people could create with that data set.
I know, right?
It's like opening up a treasure chest of coding gems for the whole world to explore.
It really is like opening a treasure chest for programmers everywhere.
Yeah.
They can take these kernels, see how the AI tackled tricky optimization problems, and maybe even adapt them for their own projects.
So it's not just a research paper, it's a whole resource that could push the entire field forward.
Exactly. And that open approach is something I find really exciting about this work.
Yeah.
It's not just about making a breakthrough, it's about sharing that knowledge and empowering others.
Yeah.
But let's get back to these KernelBench results for a minute.
Okay.
You mentioned the AI's performance got a little more mixed at level 3.
Right.
Where things got really complex.
Yeah, what were some of the specific challenges the AI ran into at that level?
Well, level 3 was all about real-world architectures.
Right.
The kind of code that powers things like image recognition or natural language processing. And these architectures can get incredibly intricate with lots of interconnected parts and dependencies.
Okay, so the code is just way more complicated.
Yeah.
What kind of problems did that create for the AI?
One challenge was that these complex architectures often rely on very specific hardware features to achieve maximum performance.
Okay.
It's like trying to fit a square peg in a round hole.
Right.
The AI had to figure out how to translate the code in a way that still took advantage of those specialized hardware capabilities.
So it's not just about making the code run faster, it's about making it run faster on that specific type of GPU.
Exactly.
That sounds tricky.
It is, and that's where the AI sometimes struggled.
Oh.
It could translate the code, but the optimized version wasn't always as fast as the original human-written code.
Yeah.
Especially for tasks that heavily relied on those specialized hardware features.
So it's like the AI is still learning the nuances of different GPU architectures.
Exactly. And that's one of the areas where researchers are focusing their efforts.
Okay.
Training the AI on even more data, exposing it to a wider range of architectures so it can become more adept at tailoring the code to specific hardware.
Makes sense. It's like giving the AI more experience so it can become a master craftsman of code optimization.
I like that analogy.
But even with these limitations, the fact that it can handle these complex architectures at all is pretty remarkable, right?
It is, and let's not forget about the time-saving aspects.
Right.
Even if the AI-generated code isn't always perfectly optimized, it still saves human programmers a tremendous amount of time and effort.
That's huge.
They can then focus on the more creative and strategic aspects of AI development,
Right.
rather than getting bogged down in the nitty-gritty of code optimization.
So it's like having an AI assistant that can handle the tedious grunt work, freeing up human programmers to tackle the bigger challenges.
Exactly, and that brings us back to the bigger picture.
Okay, the bigger picture.
Faster AI, thanks to more efficient code, could lead to breakthroughs in fields like medicine, climate science, energy, and so much more.
We've talked about the potential benefits, but are there any concerns about this kind of technology?
Well, one concern is that as these AI systems become more sophisticated, they could potentially be used to create code that is intentionally biased or harmful.
Okay, so it's not just about the AI itself.
Right.
It's about the humans who are using it.
Exactly. It's crucial to have safeguards in place to ensure that these powerful tools are being used responsibly and ethically.
That makes sense. It's like any powerful technology, it can be used for good or bad.
Right.
It all comes down to the intentions of the people using it.
Precisely. And that's why researchers are actively exploring ways to build transparency and accountability into these systems.
Okay.
They're working on techniques that allow humans to understand how the AI arrived at its solutions.
Gotcha.
So we can identify and mitigate potential biases.
So it's like giving the AI a show your work requirement so we can make sure it's not cutting corners or making decisions based on flawed data.
Exactly. And this ties into the broader conversation about responsible AI development,
Or responsible AI.
which is something we need to be thinking about as these systems become more integrated into our lives.
It's like we're entering a new era.
Yeah.
Where we need to figure out not just how to build powerful AI, but how to build it in a way that aligns with our values and goals as a society.
Absolutely. And it's a conversation that involves everyone, not just computer scientists and engineers,
Right.
but policymakers, ethicists, and everyday citizens.
Everyone.
We all have a stake in shaping the future of AI.
Well said. This deep dive has definitely given me a lot to think about.
Me too.
It's amazing to see how quickly AI is advancing and the incredible potential it holds.
It really is.
But before we wrap up, is there anything else you think our listeners should know about the future of AI-powered coding?
There's one more thing I find particularly fascinating.
Oh, okay, let's hear it.
Remember how we talked about the AI potentially tailoring code to specific hardware?
Uh-huh.
Well, researchers are already pushing that concept even further.
Okay, even further.
They're exploring ways to create AI systems that can actually design new hardware architectures that are optimized for specific AI tasks.
Wait, hold on. You're saying the AI could actually design the chips themselves?
You got it.
Like, tell us what kind of hardware we need to build to make AI even faster.
Exactly. Imagine an AI that can analyze an AI model and say, hey, to make this run as efficiently as possible, you need to build a chip with these specific features.
Wow.
It's like the AI is not just writing the software, it's starting to dictate the hardware requirements as well.
That's mind-blowing.
I know, it's crazy.
Like, the AI is becoming an architect designing the blueprints for the future of computing.
It's a truly remarkable development, and it highlights the potential for a symbiotic relationship between AI and hardware design.
Right.
As AI models become more complex and specialized, they can guide the development of hardware that is perfectly tailored to their needs, leading to a virtuous cycle of innovation.
Okay. That's definitely something I'm going to be keeping my eye on.
Me too.
But for now, I think we've covered a lot of ground and given our listeners a lot to digest.
I think so.
So to wrap things up, what's the one key takeaway you want our listeners to walk away with from this deep dive?
I think the key takeaway is that AI is evolving at an incredible pace, and its impact on our world is only going to grow.
Absolutely.
The AI CUDA Engineer is just one example of how AI can be used to solve real-world problems and push the boundaries of what's possible.
It really is.
And even if you're not a programmer, this research has implications for all of us.
Right.
Faster, more efficient AI means advancements in countless fields that affect our daily lives.
It's a great point. It's easy to get caught up in the technical details, but ultimately it's all about how this technology can make our lives better. Whether it's through faster medical diagnoses, more efficient energy solutions, or even just more personalized and engaging experiences with technology.
Exactly, and I think that's what makes this field so exciting.
Yeah.
It's not just about building cool tech, it's about using that tech to make a positive impact on the world.
Well said. And with that, I think it's time to wrap up this deep dive.
Okay.
A huge thank you to our listeners for joining us on this journey into the fascinating world of AI-powered coding.
Yes, thank you for listening.
Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible.
Couldn't have said it better myself.
It really does feel like we're on the cusp of something truly transformative.
Yeah.
AI designing its own hardware.
Right.
It's almost like science fiction becoming reality.
It is, isn't it?
And it speaks to the incredible pace of innovation in this field.
Absolutely.
Just a few years ago,
Yeah.
the idea of AI writing efficient code,
Yes.
let alone designing hardware, seemed like a distant dream.
It did.
But here we are,
Here we are.
witnessing these breakthroughs firsthand.
It's amazing.
It's like AI is becoming this self-perpetuating force,
Uh-huh.
constantly pushing the boundaries of what's possible,
Right.
and even dictating the tools it needs to evolve further.
Yeah, it's wild.
Exactly. And it makes you wonder, what's next?
I know.
What other surprising innovations are just around the corner?
Right.
Well, I, for one, am incredibly excited to see what the future holds for this kind of AI-powered coding.
Me too.
But before we get too lost in speculation,
Yeah.
let's bring things back down to earth for a minute.
Okay, back to reality.
We started by diving into this research on the AI CUDA Engineer,
Right, the AI CUDA Engineer.
a system that can write and optimize CUD code,
Hmm.
the language that unlocks the power of GPUs for AI.
Right, the language of GPUs.
We saw how it works,
Yeah.
breaking down its 4 stages,
Those 4 stages.
from translating messy code to actually making it run faster on GPUs.
Right.
We even touched on how it uses evolutionary optimization to find the most efficient solutions.
Yeah, like survival of the fittest for code.
Almost like it's breeding better code.
It really is.
And we can't forget about that impressive KernelBench performance.
Oh yeah, a hurdle bench.
The AI not only translated over 90% of the operations,
90%, that's amazing.
but it optimized 75% of them to run faster than existing methods.
Wow.
In many cases, even beating human-written code.
Yeah, that was impressive.
And what's particularly interesting is that the researchers didn't just publish their findings,
Right.
they also released a massive data set of all the CUDA kernels the AI created.
It's true, they did.
It's like they're giving away the keys to the kingdom,
I like that analogy.
inviting others to explore, learn, and build upon their work.
It's a really great example of open science.
Talk about a gift to the AI community.
Yeah, a huge gift.
But it's not all sunshine and roses, right?
Right.
We also discussed some of the potential concerns with this kind of technology,
Yeah.
especially when it comes to unintended bias
Mhm.
and the importance of responsible AI development.
That's right, we have to be careful.
Absolutely. As with any powerful technology,
Yeah.
there's a responsibility to ensure it's used ethically and for the benefit of humanity.
Right.
It's a conversation we need to continue having as AI becomes more integrated into our lives.
For sure.
And we even ventured into the realm of the future,
Yeah, the future.
discussing how AI could not only write code, but also design the hardware itself.
Right. AI designing chips.
It's mind-boggling to think about the possibilities, and a little bit intimidating, too.
It is a little bit scary.
It is a lot to wrap our heads around.
For sure.
But I think it's important to approach these advancements with a sense of curiosity and cautious optimism.
I agree.
We need to be aware of the potential risks, but also embrace the incredible opportunities that AI presents.
Right.
Well said. So for our listeners who have joined us on this deep dive into the world of AI-powered coding,
Yeah.
what's the one thing you hope they take away from this conversation?
I hope they walk away with a sense of wonder and excitement about the future of AI. This technology has the potential to transform our world in profound ways, and it's just getting started.
I completely agree.
Yeah.
It's an exciting time to be alive, and I can't wait to see what incredible innovations emerge in the coming years.
Me neither.
So to all our listeners out there, keep exploring, keep learning, and keep pushing the boundaries of what's possible.
Absolutely.
Who knows, maybe one of you will be the next pioneer in the world of AI-powered coding.
And maybe you'll even design the hardware that runs it all.
That's a wrap for today's deep dive. Thanks for joining us, and we'll catch you next time.